In this video, we're going to talk about the factored form of a quadratic. So let's just review first. Given the quadratic relation and the table of values below, we're going to graph y equals x squared plus x minus 6. So here's my table of values already done. These are my x values down here in this column, and the second column are the y values. The values have already been subbed in, all done for you, so we don't have to actually calculate them. But what we are going to do is graph it. So first I need to put a scale on my axes here. My x-axis, these are my x values right here. So I can see I've got a -3 to a +3. Now I could label it like this, 1, 2, 3, but I don't really want to crowd it in, and I don't need to crowd it in. It's going to be easier for me to graph if I spread it out a little bit. So I'm going to count by half. So each grid line will represent a unit of a half, but I'm only going to label every second one here, just so I don't get crowded. And the negative, same thing. You have to use the same scale that you used on the positive x-axis that you will use on the negative. You can't switch. So I can't start counting by something else on the left side. Next, my y values. So my lowest y value, looking down, my lowest y value is a -6. I have that twice. And my largest one is a 6. So I've got to go from -6 to 6. And in this case, let's see if I can count by halves again. So if I wanted to keep spreading it out, I might count by halves again. That would be 1, 2, 3. No, that's not going to work. So I'm going to count just by ones, but I'm going to label again every second one. That's a 2, 4, 6, 8, just to keep from getting too crowded. So if you're doing this along with me on a piece of graph paper, you need to do the same thing, and you can press pause if you want while you get caught up here. So now that my axes are done, I'm going to put the coordinates on. So remember, this is the x, this is the y. It's like there's a comma in between it. -3 and 0. Right on the x-axis, -3 and 0. -2 and -4. So if you know what you're doing, you can press pause, go ahead and draw your graph, and then come back. Skip ahead to where you need to be. -1 and -6. 0 and -6. So those two are right beside each other, these 2 points here. 1 and -4. 2 and 0. And 3 and 6. Well, I know this has to be quadratic, and I know that because there's an exponent 2 right there. So this has to be quadratic. It has to be a U shape. Even though it looks kind of like a J shape, I know it has to be a parabola. So when I draw my graph, I'm going to make it so that it is a parabola. I also notice right here that these almost look like it's flat in between these two. But because I know it's a quadratic, my graph is going to have to dip down there. So I'm going to have to do that because it is a quadratic. It's not flat on the bottom. So I'll leave that dip that's there, and I'm going to go ahead and connect my other points. So remember, you're not drawing straight lines. You are, oh, my pen faded away there. You're drawing curved lines. And I will go up from this point here. I would try to make it symmetric. My left side's a little lower than my right side. That's okay, but I didn't stop it way down here. And that's a common thing people want to do, is wherever their last dot is, they just want to stop it there, but it does continue on. The first question here, what are the zeros or the x-intercepts? So the zeros are here. I'm highlighting in yellow. Those are the x-intercepts right there. So the zeros are the x-intercepts. I'm going to write them as a coordinate. I have an x-intercept at -3, 0. And there's another one at 2, 0. So now let's review factoring. We did this back in, put it down here, in lesson 7.4. So there is another video for that if you want to go back and watch it on how to factor. So sum and product. We're looking for two numbers that have a product of the last number, that's this, a product of -6, but they also have to give me a sum of whatever my number is beside the single x term, and that's an invisible 1. So what two numbers have a product of -6 and a sum of 1? we start first with the product of 6. Numbers that have a product of 6 are 1 and 6, and 2 and 3. Those are factors of 6 that will multiply to give us 6. I'm not worried about the negative right now, I'm just looking for these numbers. Now, is there any way to arrange either of these pairs, the 1 and the 6, or the 2 and the 3, to add or subtract so that I end up with a 1? So certainly not the top. 1 minus 6, no. 6 minus 1, no. 1 plus 6, no. These two are not going to combine in any way to give me 1. But 2 and 3, I can combine those to get a 1. And that would be if I had a negative 2 and a positive 3. So let me erase this. In the space below here, once I figure out these key numbers, the key numbers that multiply to negative 6 and add to 1, which are a positive 3 and a negative 2, then I put them right in the brackets. X plus 3, X minus 2. And we have done this before, so if you've forgotten, you will have to go back and review that. So that's factored. Now, what do you notice? What does that mean? Well, obviously I'm trying to draw a parallel here between our factors and our zeros. So what I notice is that whatever I sub into this, just looking at this X plus 3 bracket, what would X need to be? What would I sub into this bracket alone to get it to turn into a 0? Well, that would be a negative 3. If I subbed in negative 3 in for X, I would get negative 3 plus 3, I would get a 0. And that's this number right here. In the other bracket, what would I need to sub in? What would I need to sub in here to get it to equal 0? Something minus 2. What would X need to be? Well, the only thing it could be is a 2. So that's this number right here. So the numbers that I get from the factors, are actually my X-intercepts. Not these two. These aren't the X-intercepts. These were the key numbers. The key numbers that got put into the brackets here. But what I really want then is to turn this bracket into a 0. And that happens when X is negative 3 or when X is 2. And that's these two numbers right here. So what do you notice? Maybe you didn't notice it, but the X values that will make each bracket equal to 0 are the X-intercepts. What am I talking about? Right? That's something kind of new. Let's expand on that a bit down here with example 1. Find the zeros without graphing. So this starts with y equals, just like up here, we have y equals, we have a table of values. So this is another quadratic, y equals x squared plus 5x plus 4, that's a quadratic. But we're not talking about graphing right now. We're just talking about finding the zeros or the x-intercepts here and here without graphing. So I know how to do that now. The x values that will make each bracket equal to 0 are the x-intercepts. So I'm going to find the x-intercepts by factoring. So factoring the first one, what are two numbers that multiply to give me 4, and those same two numbers will add or subtract to give me a 5. So our choices, what are the numbers that multiply to 4? We can do 1 times 4, or we can use 2 times 2. Are there any way to arrange either of those sets to get a 5? Yeah, we can use these ones right here. So I start with I'm going to rewrite the y equals part. Now I'm going to have two brackets, and inside the brackets are simply x's at the front, and at the back are the two numbers that we have here, which happen to be a +1 and a +4. So that is factored. But the next part of the question says find the zeros. So remember what we did up here? How did we get from factored form, sorry, that wasn't there, that was here. How did we get from factored form to the x-intercepts? We're kind of working in reverse. What would turn this bracket into 0? When x is what? So when x is what? 5? 5 plus 1? No, that's not 0. When x is like -3? No. What's going to turn this bracket to make it equal 0? What does x need to be? Well, it's got to be a -1. When x is -1, this bracket will be 0. How about this bracket? What does x need to be in this bracket to make it equal 0? In this case, x needs to be and negative 4. So those would be my two x-intercepts. If I went up to the graph up here, I would have an x-intercept at negative 1, and I'd have another one at negative 4. I don't know anything else about the parabola right now, but I would have those 2 points figured out. Next one. What multiplies to 15 and adds or subtracts to negative 8? All right, what are the factors of 15? We've got 15 and 1. They multiply together to give me 15, and 3 and 5. But I need to get a negative 8. That's not going to work. This will probably work, but I need to think about the signs. Have you got it? Think about it while I get this set up down here. So I'm going to have an x here, and I'm going to have an x here. What's going in the brackets? Yeah, a negative 3 and a negative 5. X minus 3 and x minus 5. Because negative 3 times negative 5 is positive 18, and negative 3 minus 5 is negative 8. So the next part of the question says find the zeros. So now I have to think about, well, what's going to turn the brackets into a 0? What will turn this bracket into a 0? When x is 3. And what will turn this bracket into a 0? When x is 5. Now notice I'm not writing it as a coordinate. I'm not writing it as 3, 0 here. The only reason I'm not doing that is because I don't want to confuse you with a coordinate and with this bracket here. I don't want you getting the brackets confused. This bracket means something totally different than these brackets. So I'm just leaving the number up for now. Instead of writing the x-intercept as a coordinate, I'm just writing it as a single number. So up here on the grid, I would have an x-intercept at 3, and I would have another x-intercept at 5. So the parabola maybe would be like this. Next one. Oh, next one's different. The next one is just a binomial here, just two terms. So we don't use this sum and product method when we have a binomial. So this, let me write this over here. This, what we've been using here is called the sum and product, or it's called easy trinomials. And that's what this lesson is here, easy trinomials it's called. Easy trinomials. So this isn't a trinomial, it's a binomial. So all I can do with that is a greatest common factor. So there's my y. I'm going to take out a greatest common factor of x, because I can divide an x out of here, and I can divide an x out of here. I can't take any number. I could take a negative out, but I'm not going to take out anything else. I can't take a 4 out. So x comes out. Remember how we did this? So we would rewrite the question here. We'd kind of use a big bracket, and then underneath we put our common factor, the x. So that gives us y equals, so my common factor is an x, I'm leaving that at the front. In the bracket, negative x squared divided by x. So that squared is gone, and that one's on the bottom, and I have a negative x left here, plus 4x over x, I'm left with a 4. So that's factored. Once an expression is factored, then we can find the zeros. So what turns this bracket into a 0? This one's a little harder because of that negative. What would turn that bracket into a 0? What would x need to be? And maybe you're thinking x equals negative 4. Well, if I put a negative 4 in here, let me move that over. So here's the bracket, negative x plus 4. Let's say I put a negative 4 in for the x. So that's a negative, and in for x, I'm going to put a negative 4. Well, that's going to give me a positive there. I'm going to end up with 4 plus 4. I'm going to get 8. So that's not right. So it's not negative 4. It's a positive 4. So that bracket, oh, I erased the whole thing. Well, let me just erase it all. So that second, the only bracket there, the answer for that is x equals 4, not negative 4. Now here's a weird one. This is a monomial, just a single x. Now I could put brackets around that. We usually don't put brackets around a monomial, but I could. And then I would say, what turns this bracket into a 0? Well, it's easier than it looks. The answer is subbing in for x a 0. That's what will work. If you sub in a 0 here, you're getting a 0. Anytime you have a monomial, even if I had y equals, let's say, negative 18.7x, and then x plus 2. This is a monomial. It's all one term. Everything is attached with multiplication. So that X-intercept, or what turns this into 0, is just x equals 0. Anytime you have a monomial, not a binomial, a monomial, it's always going to be 0 for the answer. So let me go up to the graph here, erase some of these older ones that I have up there in purple and put my new ones in purple just to show you. I would have an x-intercept right on the origin. That's my x equals 0, and then I would have 1 at 4. That's 4 there. So this graph would maybe look like this. Whoops, let's pretend that actually hit the, right? So we don't know about the graph yet, but we do know it's x-intercepts. So that's what we have found there. Next one, D. What multiplies? What two numbers will multiply together to give me a 36, and those same two numbers have to add or subtract to give me a negative 12? Okay, multiples of 36. There's a lot of them. You might need your calculator. You might need to do 36 divided by, well, the first one would be, put it here, the first one would be 1 in 36 for sure. Then do your get out your calculator, divide by 2, divide by 3, divide by 4. Keep going until you find a pair that will multiply to 36, but will also add or subtract to give you a negative 12. And I think once you get down to 6 times 6 is 36, I can get a negative 12 out of that if I make them both negative. So in my brackets here, I'm going to have x minus 6 and x minus 6. Again, if this is really foreign to you or you really don't remember, you need to go back and review the how to factor trinomials. Well, there's equals there, equal signs. So we've got it factored, and now we're supposed to find out what will make this 0. So what makes this first bracket equal to 0 when x is what? When x is 6. How about this bracket? Well, it's exactly the same as the other bracket. It's also x equals 6. Equals 6. So up on our graph here, which we can't really see is 6. This is 3, 4, 5. So 6 would, let's say that's 6 there. We would just have one dot there, and that graph would actually be maybe like this. It would just touch once at that point. Right there alone, it would touch the zeros, and it would only have that one there. It wouldn't have two, it wouldn't cross twice, it would only cross once. So in our last one, for example 1, again, notice it is a, oh, there's no y equals in front. Okay, so this is just a binomial. When you have a binomial, you can't use this sum and product method here. All you can do is a greatest common factor. So I'm just going to factor this out. It didn't have a y equals in front, and it's got a d instead of an x, but it's good practice. So let's take out that d. The d is the greatest common factor. Then remember, we draw a big bracket, and we rewrite the question. And underneath, we put our factor, our greatest common factor. So then in our next line, we do the division. D squared, so this d is going to divide into the d squared and leave a single d up there. Negative 0.075d is what's left there. And here, d divided by d is not 0. I don't close the bracket there. D divided by d is the same as 10 divided by 10. It's 1. So plus 1. Now what makes these brackets equal to 0? So right here, the d, remember what I told you when you have a monomial? When you have a monomial, it's simply 0. So that's 0. This one's a little harder here. To do one like this, what I'm going to do is show you, a lot of these we could do them all in our head, but some of us even maybe we're getting stuck. We weren't able to do them in our head. So here's how you figure out these brackets, especially when they get more complicated, how to figure out what they need to be. So I'm going to rewrite the bracket here. Negative 0.075d plus 1. That's the bracket. And what I'm trying to do is find out when will that bracket equal 0. So I'm going to put equals 0 there. Now I have a little equation that I'm going to solve like last year, probably when you're in grade 9. So I'm going to subtract 1 from both sides, and I will have negative 0.075d equals negative 1. I'm trying to isolate d. So I'm going to divide both sides by negative 0.075. Oh, negative 0.075. You can barely see that, but that's a negative 0.075. And these two will cancel. They're gone. That leaves me with my single d. And this part, I got to do it on my calculator. I've got two negatives that'll make a positive. So we'll just take one decimal place there, 13.3. So these are the two X-intercepts, or the two zeros of that slightly different one. It's different than the other ones we've done so far. On to example 2. Without graphing, the quadratic relation y equals x squared plus 2x minus 15, answer the following questions. A, does the relation have a maximum or a minimum value? Okay, this is another thing you're going to have to think about from before. Look at the sign in front of the x squared term. So my x squared term right here has an invisible positive 1 in front of it. Positive 1. There's no negative there. So if the sign in front is positive, you'll remember, that means your parabola is going to open up. That's your happy face. The opening is going to be at the up. The opening is going to be at the top. So my parabola is going to have that shape. Now, does that shape is the vertex a maximum or is it a minimum? That's what you're always talking about here. You're talking about the vertex. Is the vertex a maximum or a minimum? So here's the vertex right here. It's going to be a minimum. It has a minimum. And that's because the a value, that's what we call the whatever's in front of the x squared, a value is positive. So if we look back to these questions we did here, this one opens up, this one opens up, this one negative, opens down. This one, what's in front of the x squared? Positive or negative? Positive, opens up. And the last one, although it wasn't written out properly, that's a negative in front of the squared term there, so that one opens down. If it opens up, the vertex is a minimum. Part B says, what is the y-intercept? So again, this all says without graphing, right? So how am I going to get the y-intercept without having a graph to look at? Well, let x equals 0. So take my equation, y equals x squared plus 2x minus 15, and in for x I'm going to put a 0. 0 squared plus 2 times 0 minus 15. That's y equals, that's 0 plus a 0 minus 15. So y equals negative 15. That's my x-intercept. That's pretty low. So the coordinate there would be, we put in a 0 for x and we got a negative 15 for y. That's my y-intercept. Now what are the x-intercepts? Okay, for the x-intercepts, remember what you need to do? You need to factor. So I'm going to write out the question. Y equals x squared plus 2x minus 15. Now, what are two numbers that multiply to give me negative 15 and add to give me 2? Think about it. I'm going to write the answer down. I hope you got the answer in your head. So first we start off like this. What are the two numbers? So it's going to be a 5 and a 3. But to get a 2, I'm going to have to subtract. And to get a negative 15, when I multiply, one of them is going to have to be negative. Which one is it? Yeah. So we have a positive 5, negative 3 go in the bracket. So that's factored. Factoring is the first step. So after you factor, you find the zeros. So the zeros are what makes this bracket 0, what makes this bracket 0. That's what the zeros are. What makes the first bracket 0? Well, that's when x equals negative 5. And what makes the second bracket 0? So if you're struggling with this step here, I'm just going to show you what I talked about up here. If you're struggling with this step, you're thinking, I can't figure, like that's really confusing to me, I always get it wrong. Okay, I'm looking to figure out what makes that bracket, that's x minus 3. What makes that bracket equal to 0? That's what I'm trying to find out. So I'm going to add 3 to both sides. These will be gone, and I will be left with x equals 3. That's my answer. So anytime you get confused or stuck on how to do this to go from the factor to the zeros, just write it out the way I did here, or watch this video and back it up again over this spot to find out. So the x-intercepts here, therefore I'll write them as coordinates this time. The x-intercepts are -5, 0, and 3, 0, written as coordinates. Now here I just wrote them as single numbers, and that's fine too, but I wrote them out as full coordinates for you here. Okay, what's next? Example 3. It's our last example. The area of a rectangle can be represented by this relation, 15x minus x squared. Factor the expression. Okay, we're getting good at this now. This is a binomial. So when I factor it, 15x minus x squared, I'm not doing sum and product. Instead, I'm doing greatest common factor. What's the greatest common factor here? Remember how we do this? We look at the numbers first. So I've got a 15 for a number here, and I've got a 1 there. So I've got no number that's common. Then I go to the x's. In my first term, I have an x, second one I have an x squared. So I can't take out x squared out of both, but I can take x out of both. I'm going to factor it out. So my greatest common factor is an x. Then I rewrite the question with a big bracket, and I'm going to put little denominators in here, which are my greatest common factor. So I'm almost done. 15, these x's cancel out, I'm left with 15 minus, I have x squared over x, so I have 2 x's here, one of them's gone, and then that one's gone. 15 minus x, that's factored. Next question says, draw the rectangle and label the sides. Whenever you are told to draw something, you must use a ruler. If you're told to draw it and you don't use a ruler, you're going to lose a mark for form. Okay, now you can't really tell, but my tablet that I'm using here and the stylus really are not good friends with the ruler and the tablet, so it's really hard for me to draw straight things because of the tablet. But this is supposed to be a rectangle drawn with a ruler. So draw the rectangle and label the sides. Remember what the original question was? The area of a rectangle can be represented with this. So we took this expression and we factored it right here. Once it's factored, now you have, remember, area is equal to length times width. But in this format, I can't tell what the length and what the width are. So what I do is factor it, and then I can say my area is, or actually let me go over here, this is my area. So this x would be my length or my width, it doesn't matter which one. I could call this my x here, that's my length, and my width is 15 minus x, or I could write them, I could reverse their positions, it doesn't matter. So that is the length and the width, because if I take 15 minus x and I multiply it by x, I will get the original question back. So that is a representation of the area using the dimensions given in the question. Part C says, use this table to determine the value of x that will generate the rectangle with the largest area. Why are there no negative values? Okay, so here we go. X in cents. So here's our length here. When our length is 0, what's the area going to be? Well, remember our formula? Our original formula is 15x minus x squared. So if I sub a 0 in here, I'm going to get 15 times 0 minus 0 squared. That's 0 minus 0. I'm getting 0. Of course it's 0. If I have a length that is 0, then the area is going to be 0. What if the length is 5? If the length is 5 centimeters, so I take my little formula, which is 15 times 5 minus 5 squared. So use your calculator if you need to. 15 times 5, 75. minus 5 squared is 25, of course. So this is 50, and this will be in centimeters squared. So go ahead and finish the next 4 parts and press pause right now while they're blank, and then in a second you can unpause it and you'll see the answers. All right, so what happened here? Let's first talk about the second part of the question. Why are there no negative values in this chart? So the x values that were across the top, there are no negatives because x represents a dimension of a, in this question, it represents a length or width of a rectangle. So we can't have a negative length of a rectangle. So there's no negatives up here because we can't have any negatives anyway. But sometimes when we subbed in, we got negatives. Like when I subbed in a 20, you know, why did that happen? Remember, if we look at the dimensions that we got, the length, if the length is 20, so there's the yellow part, the length is 20, then the width is 15 minus 20. That would be 15 minus 20 would be a negative 5. And we can't have a negative length or a width. So that's why we ended up getting a negative answer here, which is impossible. You can't have negative area. So these two numbers, 20 and 25, didn't work when we subbed them in because once we put them in for the other dimension, it made it a negative. So we couldn't have any negative x values because we can't have negative length, but we also can't have negative area. So when we did end up getting a negative width, we couldn't use that answer anyway. What will be the greatest area? Well, from what we've got here, the biggest number, it occurred twice. Greatest area we got was to be 50, and that's in centimeters squared. That's what we found from our table. What do negative a values represent? They represent negative area, which is impossible. And the reason we got a negative area is because once we subbed in this value, this length value in the highlighted part, if x was 20, then our other dimension ended up being negative, remember? So that's why we ended up with a negative area, because one side was positive and one side was negative. Find the value of x that will produce an area of 100 centimeters squared. All right, so here we're given the area. The area is 100 centimeters squared. So I'm going to go, centimeters squared. I'm going to go back up to my formula here from the beginning. Area equals 15x minus x squared. But in for a, I'm going to put that 100 there. 100 equals 15x minus x squared. I'm looking for the dimensions. I'm looking for the values of x. But what I have to do first is bring the 100 over. So I'm going to have to turn that into a 0 by subtracting 100 from both sides. So I'm subtracting 100 from both sides. Now I'm just going to reorganize that. I'm going to put the x, this is a negative x squared, I'm going to put that first. The 15x is a positive, put that next, oops, 15x, and then the minus 100. Okay. So I've got a problem here. One we haven't encountered before is I want to factor this. Okay, I want to factor this so that I can find values of x, but I have a negative in front. And we haven't talked about that yet in this course, what to do when there's something other than a 1 here in front. So we haven't had a situation where we have a 2 here in front of the x squared or a negative. So what I'm going to have to do is take everything that I had there and I'm going to bring it all over to the other side of the equal sign, because when I add x squared to both sides, I will now have a positive x squared, which is what I can work with. And I'm going to have to subtract 15x from both sides. I'm going to subtract 15x from both sides. I'm running out of room. And I'm going to have to add 100. So let me just move all of this up here. When I do that, I have x squared minus 15x plus 100 equals 0. So now I've got a trinomial. Okay, I've got a trinomial. What are two numbers that multiply to 100 and add to negative 15. So we've got a lot of factors of 100. So I want you to press pause here. You can start with 1 and 100 if you want to, or 2 and 50. Keep going down your list until you find a pair of numbers that's going to give you a negative 15 when you add or subtract. Okay, so I'm going to guess some of us now are kind of working with 5 and 20. 5 and 20, that looks like I should be able to get a 15 out of that, right? Okay, so 20 minus 5. No, that gives me 15. Negative 20 plus 5. Yes, that gives me negative 15. Great. Except a negative 20 and a positive 5 will not multiply together to give me a positive 100. It's going to give me a negative 100. So that doesn't work. It has to fit both properties. It has to multiply to 100 and add or subtract to negative 15. So this is really tempting here, but it's not going to get us to a negative 15. And this is one of those cases we talked about previously. We could keep trying all day. We will never find them. This cannot be factored. And you always get one of those thrown in at you all the time in your homework. So this one cannot be factored. So what does that mean with this question? Cannot be factored. If it can't be factored, it means there's no value of x that's going to give us an area of 100 centimeters squared. So we look at these numbers, we got 50 centimeters squared, 5 and 10, but we're not going to be able to get 100. Cannot be factored, therefore cannot have an area of 100 centimeters squared. 100 centimeters squared. We can't get it. There's no value of x that will work. It's kind of complicated stuff there. Definitely keep your notes handy beside you when you try doing some practicing on your own.